Imagine you need a freelance contract. You type a quick sentence into a language model and hit enter, only to receive a generic document that fails to account for your specific state laws. This happens because large language models, systems trained to predict the next word in a sequence based on massive datasets, are powerful but inherently directionless without specific intent. This chart defines two parameters. The vertical axis tracks external knowledge, and horizontal tracks model adaptation. Top left uses RAG for custom data. Bottom right is fine-tuning. But for low adaptation and knowledge, prompt engineering is the primary solution. Prompt engineering provides the steering wheel for the model. Small adjustments to instructions shift the output's direction without altering the underlying weights or learned parameters of the AI. When you prompt a model in zero-shot mode, you provide no examples. The engine blindly guesses the desired format, resulting in disorganized text. We solve this using a system prompt to define a persona and provide specific examples. This is few-shot prompting. This technique utilizes in-context learning. We teach the model a specific pattern entirely within the prompt, avoiding the massive computational cost of retraining the entire system. These structural additions focus the model. They significantly reduce hallucinations, cases where the AI generates false information, and prevent it from returning shallow or irrelevant answers. Establishing context and boundaries represents the first climb up the reasoning ladder. It transforms a general prediction engine into a tool tailored for a specific, predictable task. These simple constraints often fail during complex tasks, like medical diagnosis or mathematical problem solving, where the model must perform logical deduction rather than just pattern matching. This top panel shows chain of thought, forcing the AI to think step by step. Next, majority voting runs parallel reasoning paths to select a consensus. Finally, tree of thought explores branching paths, dropping incorrect assumptions, the red X's, and following green checkmarks to the solution. Forcing the model to externalize its logic and evaluate branching paths reduces the frequency of blind guesses. This process creates a visible audit trail for deduction, allowing us to review the specific steps the AI took to reach its conclusion. Once a model can follow logical steps, we can move away from manual human inputs and build automated, self-correcting loops using the reflection pattern. In a reflection loop, the AI generates an initial response, analyzes that output for errors or quality issues, and then iterates to refine the final result. Consider an AI coding agent. It might write a script, autonomously prompt itself to check for bugs, and rewrite its own flawed code without any human intervention. We can scale this using prompt chaining. The finalized output of one reflection loop automatically becomes the input for the next task in a larger, multi-step workflow. These autonomous techniques remove the human bottleneck. The AI manages its own quality control, enabling the shift from simple chatbots to fully autonomous agentic workflows. This diagram illustrates context engineering. In modern systems, prompt engineering doesn't act alone. It integrates with external tools, long-term memory, and the current state of the conversation. These engineered contexts are used in healthcare to draft clinical notes, and in software development to generate code that adheres strictly to internal company standards. Traditional automation targets predictable, highly structured workflows. Prompt-driven models occupy a different space, navigating ambiguity and deciding how to execute messy human requests. The machine possesses the raw predictive power, but its actual performance in any given moment depends on the quality of our instructions. Mastering the prompt is how we master the model.